Hello, fifth grade, and welcome to topic 2 of math. This topic is going to focus on using models and strategies to add and subtract decimals. So we're going to be jumping into lesson 2-1. This is focused on mental math. That just means being able to solve different math problems in your head without needing a pencil or paper. Let's go ahead and watch our short video lesson together, and then we will get started with our notes and guided practice.
How can you use mental math to add? Think about this question during the lesson. Properties of addition can help you find the total cost of these three items. Would the total change if the cashier rang up the video game and then the sunglasses, or the other way around? The total cost would be the same because the commutative property of addition lets you add two decimals in any order. $11.45 plus $3.39 equals $3.39 plus $11.45. What property is shown below? The associative property lets you change the grouping of addends. The commutative property and associative property make it easy to add $11.45 plus $3.39 plus $9.55. Use the commutative property to change the order. Use the associative property to change the grouping. Compatible numbers are numbers that are easy to compute mentally. How can you use mental math to add these numbers together? Add $11.45 and $9.55 first because they are easy to compute mentally. Then add the third amount. The three items cost a total of $24.39. Now you know how to use mental math to add.
All right, let's go ahead and take a look at our notes for this section. Now, these properties are ones that you've learned before. They're ones that are going to be very familiar because we've used them as regular properties of addition when we're working with whole numbers. So the commutative property says that you can add your numbers in any order and the sum is going to stay the same. So if you have 2 plus 3, it's the same thing as doing 3 plus 2. In the case with decimals, it still applies the exact same way. So in my example question here, I can see that 1 and 35/100 plus 2 and 65/100 is going to equal 2 and 65/100 plus 1 and 35/100. So just because I'm switching the numbers, that doesn't mean that anything is going to change. I haven't added in any extra and I haven't taken anything out. All I did was move them around a bit. Now, the associative property is very similar to the commutative, but it's for 3 or more numbers. It's also called the grouping property, and it says that you can change the grouping of your addends and the sum or the answer will stay the same. So if I have my parentheses over here around 1 and 35/100 plus 2 and 65/100, and then after I complete that, I want to add 7 and 1/10 or 10/100. I can decide to move those parentheses around the 2 and 65/100 and the 7 and 10/100 instead, and do that first before I add the 1 and 35/100. So all I'm doing is I'm taking the parentheses and I'm going to group them around a different set of numbers. Now, another strategy we can use is called compatible numbers. So compatible numbers are numbers that are close to your original numbers and they're easy to add. Now, compatible numbers do not need to follow rounding rules. They're just numbers that are easy to work with. So if I did 1 and 35/100 plus 2 and 65/100, I can change the 1 and 35/100 to 1 and 25/100. I can change the 2 and 65/100 to 2 and 75/100. Now, if I'm looking at this and thinking about it like money, $1.25 plus $2.75. I know the 25 and the 75 are going to make a whole dollar. Plus another one, that's $2, plus another two, that's $4. I can also use a strategy called compensation. Now, compensation is either adjusting one of the numbers or both of the numbers to make calculating easier. Now, over here, I have 4 and 25 hundredths minus 8 hundredths. Now, to make this easier, it's easier for me to take away tenths. So I'm going to add 2 hundredths, so 0.02 to this 0.08. And then I'm going to subtract 4 and 25 hundredths minus 10 hundredths. So 25 minus the 10 is going to leave me with 15. So 4 and 15 hundredths. Now, since I added in 2 hundredths extra, I need to take them back out. Whatever extra you put in, you need to remove so you can get back to your original answer. And that will leave me with 4 and 13 hundredths. Another example that I put in here is 3 and 47 hundredths, or 3.47 plus 4.35. Now 3.47 is really close to 3.50. So it's only 0.03 away. So I'm going to add 0.03 or 3 hundredths to it. And then I'm going to do my addition. So 3 and 50 hundredths plus 4 and 35 hundredths leaves me with 7 and 85 hundredths. So the 50 plus the 35 is 85. The 3 plus 4 was 7. Now I added in 3 hundredths extra. So I need to take out that 3 hundredths from my answer. So 7 and 85 hundredths minus those 3 hundredths extra that I had put in will leave me with 7 and 82 hundredths. Now with compensation, you can add some extra into your original number or take some out to make it easier to use to do your mental math. But remember, any changes that you make, you must undo those changes to find your correct answer. Now, compensation can also work a different way. You can pull from one of your numbers and move a part of one of your numbers into another number. In that case, you're not adding in anything extra or taking out anything you shouldn't be taking out. All you're doing is moving things around from the numbers that you already have. So in these two examples, the extra that we added in, we took out at the end so that we can get to our original answer. Let's take a look at some examples. First example says 3 pieces of software cost $20.75, $10.95, and $18.25. What is the total cost of the software? Use mental math. So what I know is there are 3 pieces of software, and I listed the prices for them. Now here I can use the associative property to help me solve. So if I have 20.75, 10.95, and 18.25, I'm going to group my 20.75 and 18.25 because I know the 75 plus the 25 is going to give me a whole number answer when I put it together. So I group those, the 20.75 plus 18.25, and then afterwards I'll add the $10.95. So when I added these two numbers together, the $20.75 plus the $18.25, I got a total of $39. $39 plus the $10.95 equals $49.95. Now, I can also use compensation, and this is the way that I was just talking to you about. I can move that 25 cents from the $18.25 and add it directly into the $20.75. So now I'm not putting in anything extra. This is part of my original numbers. I'm just regrouping it. So if I take that 25 cents and add it to the 75 cents here, it's going to make a whole dollar. So this is going to become $21 plus $18 plus $10.95, which again will give you $49.95. Now to check my answer, if I want to see if my answer is reasonable, I can use compatible numbers to estimate my answer. So the $20.75, I'm going to leave that at $20, my $18.25, that's about $20, and my $10.95, I'm just going to make that $10. And I put those together and that equals 50. Now, notice how the numbers are not following a specific rule. I'm picking any numbers that are close by that are easy to work with. All right, let's take a look at your guided practice. Number 1 says, show how to use compensation to add $3.18 and $6.50. Now for my $3.18, I'm going to add 2 more cents and make it $3.20. So $3.20 plus $6.50 will give me $9.70. Now, since I added in 2 cents extra, I need to subtract those 2 cents back out. So $9.70 minus 2 cents is $9.68. Number 2 says use properties to rewrite the expression to be easier to solve and then explain. So I have 13 plus 4 and 63/100 plus 7 and 4/10. Now, I'm going to rewrite this using my associative property, and I'm going to group the 13 and the 7 and 4/10 because I know 13 plus 7 is 20. So 20 plus 4/10. And then I can add the 4 and 63/100. So the 20 plus, or the 4/10 or the 40/100 plus 63/100 will give me 1 whole plus 3/100 extra. So the 20 plus the 4 plus the whole extra will give me 25. And then plus the 3 cents that I had left over is going to be 25 and 3/100. So if you work through this question, the 13 and the 7 made a 20. And then that 0.4 also stayed on the number. So 20.4 or 20 and 4/10. Then I added my last number, 4 and 63/100. Now I know 4/10 and 6/10 or 40/100 and 60/100 will give me 100 total. 60 plus 40 is 100. So that's how we made that whole. But we still also had these 3 extras over here, the 3/100. So if you're looking at this like money, if it was $20.04 and 40 cents plus $4.63, we know the 40 plus the 63 is going to give us $1.03. Plus that 20 is $21.03. Plus that 4 is $25.03. For number 3, we're going to use compensation and then the associative property. So I have 12 plus 3 and 4/100 plus 8 and 28/100. So I'm going to take that 4/100 and I'm going to add it on to my 8 and 28/100. So that's going to leave me with 12 plus 3. So now I have 2 whole numbers plus 8 and 32/100. So I used compensation. I moved some from one into another to make it easier. Now the 12 plus 8, the 12, I'm going to group it as 12 plus 8 and 32/100 because I know 12 plus 8 is going to give me 20. So 20 and 32/100 plus 3 whole is going to give me 23 and 32/100. So first I used compensation to move the decimal value from one number into the other. Then I used my associative property to change the grouping so that I could add easily, and then I was able to solve. For number 4, 6 and 97/100 plus 4 and 15/100. So 6 and 97/100 is almost 7. It just needs 3/100 more. So I'm going to take 3/100 from the 4 and 15/100, and I'm going to move it over into the 6 and 97/100. So now that'll make 7 whole plus 4 and 12/100. So 7 plus 4 and 12/100 is 11 and 12/100. So again, I took out that 3/100 out of the 4 and 15/100, and then I moved it over to my other number. Number 5 says 9 and 4/100 minus 6 and 98/100. So I'm going to subtract off, or I'm going to move 2/100 from the 9 and 4/100, and I'm going to move it over to the 6 and 98/100 to make it 7 whole. So now I can take, now my numbers are going to be 9 and 2/100 minus 7, which is going to leave me with 2 and 200. So I used compensation to move a certain amount from one of my numbers into the other to make it a whole number. And then I was able to solve my question. Now my last one says 4 and 200ths plus 1900ths plus 16 and 4800ths. So 48 is almost 50. So I'm going to take the 200ths from the 4 and 200ths, and I'm going to move it into the 16 and 4800ths. So that's going to leave the 4 whole. It's going to make the 16 and 4800ths into 16 and 5000ths. And then I have the 0.19 or the 1900ths. Now I know 4 and 16 is going to give me 20. So 4 plus 16 and 5000ths is going to give me 20 and 5000ths, so 20.5. And then I'll add 0.19 to it. So 20.50 plus 0.19 is going to give me 20.69 or 20 and 6900ths. So I use compensation in the beginning to move a part over from one number into another to make it easy to work with. And then I use my associative property to work with the grouping and set it up so that it's easy for me to solve. That takes us to the end of our lesson. Remember, you have multiple strategies you can lean on to solve and use mental math. You can use the commutative, the associative, you can use compatible numbers, or you can use compensation. All of those are different ways that you can complete a problem using mental math. If you have any questions, let me know. Otherwise, have a wonderful day. Take care. Bye-bye.